All right, in this video, we are going to learn one application of the greatest common factor, and that is to use the GCF to simplify fractions. So we just have one vocabulary term today, that is simplifying. To simplify something, we can do that with fractions. We can also do that with algebra. But in this case, we're just going to talk about fractions. It means to rewrite something using smaller numbers, or like make it simpler, make it smaller, make it look prettier, but it still has the same value. So you haven't changed the mathematical amount, you've just made it look nicer. All right, so let's look at an example. So we are going to simplify the fraction 8/16. So take a minute, think about that. Do you already know how to do this? Could you know how to simplify that fraction? If so, that's awesome. Think for a minute, see if you can figure out what it is. If not, that's okay. I'm going to explain. All right, so I've drawn a little model of 8/16. I've drawn 16, or I've put a rectangle around 16 boxes, and I've shaded in 8 of them. Now, it's a little bit hard to that was kind of annoying to do. I didn't super love it. I can do the same thing, but show it more simplified by showing that all this is half of the boxes, right? Rather than picturing it broken up into all 16 little separate pieces, I can picture it as being 2 pieces, and I'm just taking half of them. It's the same amount either way. And that's because 8/16 is equivalent to 1/2. And the way we know that is that 8 is the GCF. 8 is a factor that goes into both 8 and 16. I'm saying 8 is the GCF of 8 and 16. And so if I were to divide both the 8 and the 16 by 8, 8 divided by 8 would give me 1, and 16 divided by 8 would give me 2. All right, let's do our next example. This time we're going to simplify 4/36. So try and think about what is a factor that can go into both 4 and 36. Well, maybe this feels similar to you with what we've been doing with the cake method. So let's go ahead and try it using a cake. So I need to know what's the biggest number that goes into both 4 and 36. 4 and 36. So I'm going to set it up like a cake. I'm going to put the 2 numbers in my fraction inside the cake. Well, looking at those, I can tell they're both even numbers, right? 4 and 6 are both even numbers, so that means that 2 must go in. When I divide, 4 divided by 2 is 2. 36 divided by 2, ooh, gotta break that in half. 30 in half is 15, 6 in half is 3, 15 plus 3 is 18. Great. And then, hey, look, those are still even numbers, so I can do it again. 2 divided by 2 is 1. 18 divided by 2 is 9. All right, so now I wanted to find the GCF. So that means just the numbers on the side. So the GCF is 2 times 2 gives me 4. So I now am going to divide by the GCF. So I'm going to do 4 divided by 4 and 36 divided by 4. And 4 divided by 4 gives me 1, and 36 divided by 4 gives me 9. Now, 1 and 9, those should look a little bit familiar to us because 1 and 9, those were the same numbers that happened down here. I want you to think for a minute, why is that happening? Is that a coincidence, or is that always going to work? So hopefully you're thinking that that's always going to work, because that's essentially what I've done in the cake, right? Is I've just divided 34 by 4 to get 1, and 36 by 4 to get 9. I just did it in 2 different steps. I did it first by 2 and then by another 2. But that will always work. Those 2 leftover numbers in your cake are always going to end up being the simplified version of the fraction. All right, another example. I want you to try and do this one on your own. You're going to simplify 30 105ths. Pause now, give it a shot, make a cake if that's a helpful method for you, and then press play when you think you have it. All right, so when I started making this cake, I looked at this and I thought, well, 2 is usually my first go-to move, but I can't do that here because 5 isn't divisible by 2. Oh, but 30, that's a multiply of 10, and then I've got a 5 there. I bet 5 goes into both. So I'm going to start by dividing by 5. 5 times 6 is 30, so the 6 will go down below. And then 105 divided by 5. Well, I know that's 21 because I know that 100 divided by 5 is 20. And so if it's 105, there's just one extra. Sorry, 100 divided by 5 is 20, so 105 would be just 21. Okay, and then let's see. So now I've got 6 and 21. There's still odd numbers, but something looks, okay, let's just try it. So 2 isn't going to work, but 3. 3 goes into 6, and 3 times 7 is 21, so 3 will work. So that gives me a 2 and a 7. And both 2 and 7 are prime, so definitely no further I can go here. All right, so now I need to find the GCF. So the GCF is going to be those side numbers multiplied together. So 5 times 3, getting ahead of myself there. 5 times 3 is 15. So that means that my common factor is 15. So I'm going to divide both by 15. And then I'm going to be left with these 2 numbers down below. So that's going to equal 2, which makes sense. 30 divided by 15 is 2. And 105 divided by 15 is 7. Well, my math told me that was true, so I'm going to trust it. So my final answer is 2/7. All right, for your practice problem, I need you to simplify 12/56. You can make a cake if that is helpful to you. Be sure to write it in its most simplified form like we've been doing in this video. Good luck.